طيب بسم الله الرحمن الرحيم. So we last time we continued the discussion regarding the flow control and error control for the noisy channels, where we account for uh, uh, corrupted packets and corrupted acknowledgements and corrupted and lost packets and lost acknowledgements. We started to talk about stop and wait, where we have only one frame to be sent at any point of time. And we have motivated, or we have concluded that stop and wait is not good for utilizing the channel efficiently, in which case we talked about go back N. For go back N, we continue to receive everything in order, in which case the receiver has only one pointer pointing to one place, and it expects to receive everything in order. And because of this, if any frame is lost, the biggest disadvantage for go back N is to go back from the beginning of the sender window and send everything from the beginning. So this disadvantage of go back N was because of the fact that everything is expected to be received in order. So for selective repeat, we try to accommodate out of order reception at the receiver. So in order for the sender not to go from the beginning of the window and send everything if one packet is not received by the receiver has to accommodate out of order delivery of the frames. So the design of the sender itself, as we can see, it's exactly the same. So we still have the window, which, as we discussed before, divides the horizon into some frames that have been sent but not acknowledged, and some frames that have not been sent yet, but I can send as long as they are within the window. And the main reason for this window is to utilize the channel more efficiently by sending up to n frames without having to wait for acknowledgement. So that was good. The problem here is that if for any reason the timeout expires, the sender for the go back in will have to go back from the beginning. So in order for the sender to avoid sending everything from the beginning of the window, then we have to design significantly, we have to redesign significantly the receiver to allow the receiver to accept the frames even if they are out of order. This is the only way for us to avoid resending every frame in the window. So as we can see, the design of the sender window is exactly the same. Everything is the same. We have the start pointer, we have the current pointer, and we have the SW, or the window size, except that the SW, as we can notice here, the SW is 2 to the power m minus 1. Notice here the m minus 1 is in the exponent, not in line. So which means that the window size for the sender and the window size for the receiver, as we will see, is less than or equal to 2 to the power m minus 1, which means half. Okay, which means half. So other than this, the design of the sender is exactly the same. Now the receiver has a very funny situation. As you can see, in order for us to force the receiver to receive frames out of order, then we have to have another window at the receiver side for all the frames that are allowed to be received by the receiver, even if they are out of order. So that's what we what we are illustrating here. So at the receiver side for the selective repeat, we have another window which is exactly similar to the sender window. And now Rn points to a frame that has not been received yet. Okay, Rn always points to a frame that has not been received yet, but for that case, it's frame 3. However, the receiver may accept frame 4 even if it's out of order. It may accept frame 7 even if it's out of order, as long as it's within the window of the receiver. And again, the receiver window size, similar to the sender window size, is at maximum 2 to the power m minus 1, or half the sequence number. And we will see again why, although we talked about it last time, but we will see visually again today why we need to have the sender window size and the receiver window size, each of them half the sequence number. All right, so the main thing here is that the reception is allowed to be out of order in general. Okay, so this is very, very important. So this is the fundamental difference between go back n and selective repeat. For go back n, out of order reception is not allowed by any chance. So therefore, we have a receiver window size of 1. We don't have a big receiver window for the go back n. Okay, type. So another difference here. So this is يعني one fundamental difference. Another difference here is that if I receive things out of order, okay, this means that frame 3 has not been received. Okay, so in that case, I need to inform the receiver, the sender. I need to inform the sender to resend that particular frame. It may be frame 3, it may be frame 5, it may be frame 6, right? So if I receive frames out of order, I need to send back to inform the sender that it needs to send this particular frame. So now this type of acknowledgement is of a special type now. So we want to inform the sender that we did not receive this particular frame, please send it. Okay, so in go back n, we used to say, okay, so this is the last frame I have received successfully. So here we want to tell the sender, please send this frame because it has not been received. So in this case, we have a special type of acknowledgement. We call it negative acknowledgement. Okay, negative acknowledgement. This negative acknowledgement is sent from the receiver to the sender to inform the sender that this frame has not been received yet. And remember, this type of negative acknowledgement is not cumulative. It's not cumulative, right? So unlike go back n, which we said that acknowledgement is always cumulative, right? Which means that if the receiver receives 3 frames all at the same time, it needs to send only 1 acknowledgement for the last successfully received frame. Here, negative acknowledgement is not cumulative because we are trying to tell the receiver, we are trying to tell the sender, we did not receive that particular frame, which is supposed to be in order, okay? So please send it so that, okay, I try to keep things in order, okay? That doesn't mean that I would not accept the frame out of order. I will still accept the out of order frame, but I need that frame so that I can keep things in order. Okay, كده? So, so negative acknowledgement is an extra overhead which I have to account for at the receiver side. Okay, طيب. So this is at the receiver. One thing that we notice also is that if the sender times out now, If the sender times out, now the sender doesn't have to go back from the beginning. That's why we're doing all of this, right? So the sender, when it times out, it doesn't have to go from the beginning of the window and send everything, okay? Which means that the timer itself, okay, tells me the sequence of the frame that has not been successfully received at the receiver, or in other words, the frame that has not been acknowledged by the receiver. Okay, so that I can send only this particular frame and not the entire window. This implies that at the sender, I need to keep multiple timer. I need to keep timer per frame, not timer per window. Okay, so I need to keep one timer per frame, not one timer per window. This is also very important, as we will see in a minute. So these are the main differences when it comes to selective repeat. There are some other minor differences that we will talk about. So that's the overview of the selective repeat. The only thing that we notice as a difference between selective repeat and go back in, we notice that all the events are the same. We still have the three major events at the sender. We still have one event at the receiver, as usual. So starting from stop and wait and go back in and selective repeat, we have the same types of events. The only difference we notice here is that at the receiver side, we have another window, okay? And here, this red location tells us that we are allowed to receive frames out of order. So this is the main difference that we have in this case, and we will see that the handling of these events has changed or significantly, as we will see. Type. So remember that for go back n, we said that the window size for the sender, okay, is maximum 2 to the power m minus 1 in line, okay. This one is technically the window size at the receiver, because the window size at the receiver was actually 1, because everything is in order. So we only need one location to point to the frame that I'm expecting at this point. Here, for the case of selective repeat, the window size at the sender and the window size at the receiver, okay, are both half the sequence number. Half the sequence number, which means that the -1 is in the exponent, not a inline. Okay, which means that each one is actually half. Okay, so how do we prove this, or how do we see this visually? This always happens for the worst case scenario when the two windows are stuck. When the two windows are stuck, what happens is that these two windows have to be concatenated together, and when you concatenate both windows, all the sequence number inside both windows, they have to be different. So that's the scenario here that illustrates this. So imagine if we have the normal case where we have a window size of 2 and we have 4 sequence numbers. So in that case, the window size for the sender is half the sequence number, okay? And the window size of the receiver is also half the sequence number. So in this scenario, everything is fine, okay? So for the case of, for this case, if the sender tries to send frame 0, okay, so in that case, the receiver receives frame 0, and the receiver, when it receives things in order, it slides the window, okay? Similar to go back n. For go back n, when things are in order, we increment Rn, right? So if things are received in order, we increment Rn, which means here that we slide the window at the receiver side. Okay, so when we receive also frame 1, we slide the window. All the acknowledgements here, as we said before, are lost. Okay, which means that the backward channel is erroneous, and the sender almost never receives any acknowledgement. So in that case, as we can see, the window at the sender and the window at the receiver are both stuck, and they are concatenated together, right? So you can combine them. So in that case, when طبعا of course here there's something that's not shown here, that when I send frame 1, I also have to start the timer, by the way. As we said, we have to start a timer per frame in that case, right? So that's not shown here. So when we start to send frame 1, we also have to start another timer. All right, but anyway, so the timer for frame 0 has expired, so we have to resend frame 0. When we send frame 0, right? So for the receiver will say, oh, okay, so frame 0 here, okay, I'm not expecting any frame here with sequence 0. I'm expecting a frame either with sequence 2 or 3. What I have received is frame A 0. So frame 0 is outside the window, so sorry, I cannot accept it. So the receiver will correctly discard that frame, and it will keep things as they are. Okay, so when frame 1 expires here, again the sender will send frame 1. Okay, again frame 1 is outside this window. I'm expecting frame 2 or frame 3. So frame 1, sorry, I cannot accept it, so it will be discarded. Okay, so frame 1 and frame 0 will keep timing out, and the situation will get stuck at this point, right? So when I receive the frame 0 or frame 1, I cannot accept them. I will discard them, and then I say that I need this frame 2. So until one of the acknowledgement at least reaches the sender will then start to send frame 2, and things will move on. However, even if no acknowledgement has been received by the sender, the situation will be stuck like this and will correctly work. Okay. So imagine that for this case, that the window size, as we can see here, the window size here is 3, and the sequence number is 4. So this condition here is not met. This condition, sorry, is not met, right? So so in that case, we can see that when the sender sends frame 0, okay, and the receiver will accept it because it's within the window, right? When it accepts it and it finds that it's in order, so it will increment, which means it will slide the window. The acknowledgement has not been received by the sender, so sender will continue on sending frame 1 and frame 2, and for each one it has to start a new timer, and for frame 2 as well. So for each frame we have to start a timer. Okay, so now the frame or the windows at the sender is actually stopped here. So when frame 0 expires, it will send frame 0 again, and unfortunately frame 0 is part of the window now, so frame 0 will erroneously be accepted, because remember, the frame 0 here is this one, right? So this frame 0 will be accepted as if it is this frame 0, which of course is a wrong situation, and this will cause a full corruption to happen for the receiver. So this scenario of work will not work correctly as designed. So it's very, very important for us to keep both the sender and the receiver in sync and working correctly, that this condition has to be met. So this condition has to be met at all times. واضح كده يا شباب؟ Any questions? Any questions so far? Mm-hmm. Mm-hmm. For the case A يعني. Okay. Yes. Yes. True. Yes. Exactly. Exactly. And it will keep waiting for frame 2 and 3 until the sender sends frame 2 or frame 3. But the sender will only send frame 2 and or 3 if it receives at least one single acknowledgement, because the sender here slides under one condition. The sender always slides under one condition. If it receives a positive acknowledgement, in that case, it will slide the window. When it slides the window, frame 2 and or frame 3 will be inside the window, in which case the sender can send them. Okay, but here we're talking about the worst case scenario, that the feedback channel is erroneous and the acknowledgement is not getting to the sender. If that worst case ever happens, okay, so we'll get stuck and we'll work as designed, but there's no corruption. There will be تفضل at the receiver. All right, so in that case, this is the theorem now, or this is the proposition that the selective repeat, the sender of the window and the sender of the sender of the sender, the window size of the sender and the window size of the receiver, both have to be half the sequence number, which is 2 to the power m. Okay, that's the conclusion now. So now we talk about the pseudocode for the sender. We notice here that the pseudocode for the sender, again, we have at a high level point of view, we have the 3 events. We have the request to send coming from the network layer. We have arrival notification coming from the physical layer, which we have to check for any corrupted data in that case. And we have the timeout, right? So to handle these events, we notice that at the sender side, the changes are very minimal, because again, for the sender, it's exactly similar to the go back in, with only slight modification here. Can anyone يعني try to spot where the difference here, at least in the request to send? What differences are you noticing here? There's one slight difference compared to go back in. So what is the main difference for the case of selective repeat when it comes to the sender? Anyone can notice anything here? The start timer? Why is it at the end? Because when we send, we have to start the timer. Okay, the timer can happen here or here or here, it doesn't matter. Okay, it doesn't matter, but there is a slight difference for this at the sender side. There's a slight difference, one minor difference here. And by the way, start timer for go back in was actually at the end as well, but there was a slight difference. Any idea? Okay. So if you notice, for the case of go back in, here, the start timer here was working like this. If timer not running, then start timer. And when we start timer, we don't specify anything here. Why? Because as we said before, the timer is one timer for the entire protocol, one timer for the window, right? So we do not have to start the timer every time we send a new frame. It starts at the beginning and that's it, right? Here, as we said, because we are maintaining one timer per frame, So we have to start the timer every time, and the timer has to store the sequence number of the sent frame. This is very important. So this is big. This is the big difference now, that the timer itself has to store this. Why? Because when it expires, I need to send only that particular frame. I don't need to send all the frames from the beginning of the window. I only need to send that particular frame only. واضح كده يا شباب? So this is the main difference when it comes to the sender, that the timer is one timer per frame, not one timer per window. So I don't need to check if the timer is running, because every time I will start a new timer. واضح كده؟ The other slight difference here is that when we receive something from the physical layer, of course, we have to check for corrupted bits. Okay, if there is corrupted bits, then I don't know whether this is negative acknowledgement or positive acknowledgement or anything else. Then in that case, I don't have to do anything. So when we receive a frame from the physical layer, as we said, the rule is we always have to check for corrupted bits type. If it's not corrupted, then again, unlike the go back N, we have another type of acknowledgement, which we said will indicate that this particular frame was not received, okay? And this type of acknowledgement is not cumulative, which is negative acknowledgement. So if the frame type is negative acknowledgement, then we have to know that this negative acknowledgement indicates a particular frame was not received, okay? And this this negative acknowledgement is not cumulative. So the only thing I need to do is just to check that this negative acknowledgement number is within the window of the sender, and if it is within the window, then the only thing I need to do is just to resend this frame again, only one frame. And as we said, this is a not cumulative. So in that case, I don't need that to go through the frames in the window one by one. It's only one frame that I need to send. And we will see what condition based on which we receive, or the receiver actually sends that negative acknowledgement. The receiver always sends that negative acknowledgement when there is a frame received out of order. When there is a frame received out of order, we always send that negative acknowledgement. That does not indicate that we will not accept the out of order frames. We will accept them, but we are trying to bother and nag the sender to send us the in order frames so that we can keep things in order as much as possible. And we will see again why now. So when I send, I will have to start frame. I will start timer. So when I resend that particular frame, I start timer. Okay, type. The other type of acknowledgement, which is still there, by the way. So this acknowledgement is now a cumulative value. So negative acknowledgement is not cumulative, but acknowledgement still is. Acknowledgement still is cumulative. So in that case, receiving acknowledgement, this means that I received up to this frame correctly in order. Okay, so you can slide the window and you can send me the next frame. So if this acknowledgement is within the window, then in that case I need to slide. And sliding at the طبعا احنا هنا, this is SF and this is SN, as we said before. So what we need to do is now to move SF towards SN, right? So that's what sliding means. And for all these frames, we acknowledge them. We mark them as received and acknowledged, and we can purge them. So purge here, because we have to keep a copy, as we said, so that when we want to retransmit. So by sliding, we mean that as long as this acknowledgement number is the acknowledgement number is less than the SN, so we keep sliding. So SF will keep incrementing until we reach to SN. واضح كده؟ So, and every time we stop the timer, because we have a timer per frame, so we have to stop every single timer that we have running for this particular frame. طيب, so we're still at the sender side. So this is the whole point of selective repeat. So we have done all of this because of the timeout. So when the timeout happens, remember, for the case of go back n, we used to loop from SF all the way to SN and resend everything again, right? And this is the biggest problem for go back n. Here, when the timer happens, the timer itself tells us the frame sequence number that we have to send. So in that case, we resend that frame and we start the timer. Okay? So when you have consecutive statements like this, so you can start the timer first or last, doesn't matter. And someone was actually asking, why do we have to start the timer at the end? It doesn't matter, as long as you have consecutive statements like this. If you send the frame first and then you start the timer, or start the timer first and send the frame, it doesn't matter. The sequence doesn't matter. ماشي كده يا شباب؟ So this is the sender side. The receiver side بقى is the significant change, because the receiver side now will have to maintain a window. So remember, the receiver side has a situation that looks like this. So you have a window, okay? You have Rn here, and Rn always points at a location that has not been received yet. And we'll tell you why now in a minute, okay? So, and then just the fact that Rn is pointing to a frame that has not been received, it doesn't mean that the frames after this have not been received. It could be that you have a situation like this, and then you have a gap, and then you have another frame received like this, right? So this is the funny situation the receiver is in now. So the logic now is that I will tell you the logic in summary, and then we will go through the code to understand this better. So now the receiver is expecting frames of two types. Either a frame that fills a gap like this. If the receiver receives a frame that fills a gap, this means that all of these frames now have been received and in order, okay? Or it may actually receive that frame again, which means that this frame is duplicate and it's already been received before. When does this happen? When does the receiver receives the same frame twice? If the receiver receives that frame the first time, it sends the acknowledgement to the sender. The acknowledgement to the sender has been lost, so the timer for that particular frame at the sender times out, so the sender will resend that frame again, which will arrive at the receiver, and the receiver will say, oh, okay, so I received that frame before, so I don't have to do anything. So when you receive a duplicate frame at the receiver, you don't have to do anything. Okay, so you don't have to do anything now. You just discard it and that's it. So the receiver is most importantly waiting for frames that fill some gaps, right? So when it receives a frame that fills some gap, that's when it starts to say, oh, okay, so does it fill a gap? Yes. So we have now consecutive frames. These three frames are consecutive, okay? We don't have any gap in between. So we can send them up. Okay, so now we can send them up to the application. So this is the most important thing I'm waiting for. I'm waiting for frames that fill some gaps in the receiver window, because when it fills a gap, this means that we have consecutive frames that we can send up. This means that, remember, just the fact that the receiver might accept frames out of order, it cannot and it must not send the out of order frames to the network layer, to the upper layer. Okay? Again, so just the fact that the receiver might accept some frames even if they are out of order, that doesn't mean that we can deliver these frames up. We can only deliver frames up when they are in order. Okay? So delivering frame to the upper layer must happen in order in all cases, whether we're talking about stop and wait, selective repeat, go back, and anything. Every single delivery that happens to the application, to the higher layer, has to always be in order. Okay, but we are allowing the frames to be received at the socket buffer of the or at the receiver window out of order, just to avoid the fact that we don't have to resend the same frame repeatedly from the sender. Yes, frames that are duplicated will be discarded. Yes, I don't have to do anything about them. So I'm particularly waiting for frames that fill some gaps here or something like this, because when a frame fills a gap, then we have to ask ourselves, do we have consecutive frames in order? Because if that's the case, then I need to send them up to the upper layer. That's what I'm looking for. Okay, so let's go through the code now. So when the receiver has only one event, which is arrival notification. So remember, the arriving frame now first might be corrupted, and as we said before, we always have to check for corruption. Second, this frame, if it's not corrupted, it might be a duplicate frame, right? And it might be a new frame. If it's a new frame, now we can see if it fills a gap and so on and so forth. Okay, so these are the three cases that we have. So for the first case, and I need you, by the way, as a common thing, I need you to forget completely about this flag, which will simplify the logic a little bit. So this flag, by the way, remove it. It has no use, and I'll tell you why now. This is called negative acknowledgement sent. Okay, I don't have to maintain that flag. I can remove it from the code completely, and the code will still work as designed. And if in the exam, if you don't actually mention that flag at all, I will consider your answer perfectly correct, 100% correct. Okay, and I will tell you why now. So again, if we receive a frame, then first we have to check for corrupted frame. If the frame is corrupted, okay, for all the previous cases, if the frame is corrupted, we don't do anything because we cannot do anything. Here, there is an exception. If the frame is corrupted, then most probably this frame is the frame that's coming to the location that RN is pointing to, okay? And because this frame is corrupted, I need to inform the sender that there is a frame that has not been received. This is the exception now. So it's better. Again, if you don't do this, it will still work, but it's better in that case to send negative acknowledgement with RN. Okay, so again, when do we send negative acknowledgement? If we receive a frame out of order, which means that the frame sequence number is not Rn, okay, or when we receive a corrupted frame. واضح كده؟ طيب, so if we receive a corrupted frame, we send negative acknowledgement with Rn. The negative acknowledgement always is Rn, by the way, because Rn is the frame that I'm expecting in order. So I will keep nagging the sender that you are sending me frame Rn plus 1, but I need Rn. You are sending me frame Rn plus 2, but I need Rn. Okay, so every time you will send me Rn plus 1 or 2 or 3, I will tell you I need Rn, I need Rn. So I will keep nagging the sender that I need Rn, I need Rn all the time. Okay, so again, as you can see here, the frame is corrupted. Send negative acknowledgement with Rn. The sequence number is not Rn. Again, send negative acknowledgement with Rn. Right? So I will keep nagging the sender every time I receive a corrupted frame or a frame that's not pointing to Rn. Okay? So if the frame is corrupted, send negative acknowledgement. If the frame sequence number is not Rn, also send negative acknowledgement. So these are the two conditions based on which the receiver will receive, or the receiver قصدي will send negative acknowledgement. طيب, if خلاص بقى, so again this next send, as we said, next send ده خلاص remove it. Okay. طيب, so now بقى, if the receiver receives a frame and the frame is in the window, right? Then there are two possible scenarios now. Either the frame is duplicate, or the frame is actually new frame that fills a gap. Either the frame is duplicate or the frame is filling a gap. If it's duplicate, then we have to say that if it's marked as received, خلاص, we don't do anything. So only if it's not marked as received that we do anything. Why? Because we said that if the frame is duplicate, we don't do anything, right? So only if the frame is a new frame that's not marked as received, okay, we will accept it, and then we'll do what's next. All right, again, remove this. طيب, so now we are in the situation that, so we have Rn here, and Rn is pointing to a frame that has not been received. We may have something here, and we have something here, and we have these gaps in between. So getting here, this means that we have a frame that fills the gap here or here, because this marked as received is false, which means that this frame is a new frame. واضح كده? So either this frame is filling this gap or this gap. Okay? طيب. So in that case, we will take the frame, we'll store it. خلاص, احنا will accept it as long as it's either this or this, it's still within the window. So we'll accept it. Okay, because it's not marked as received. And then we will mark this frame as received. So let's say this is this frame. Okay, so we will mark this frame now as received. So that if this frame comes again, we'll detect that this duplicate and we don't do anything. ماشي? And now بقى, imagine بقى if this frame is this one, then while marked as received Rn, so Rn is not received, so in that case I will stop. Right? So I will not do anything because Rn is not marked as received. But imagine بقى if that frame is here, okay, and this frame and this frame is not the one that's received, so this frame is not received. Okay, طيب. So that's the situation now. I received frame at Rn, right? and I have a gap here, and that's the situation. So in that case, Rn will be marked as received. So what do I do? If Rn is marked as received, then I'm receiving now something in order. I'm receiving something in order. Rn is in order, the one after it is in order, the one after it is in order, and then there is a gap. So in that case, I can start delivering these frames to the upper layer. So as long as the frame marked as Rn is received, I will deliver this frame to the upper layer, purge, and Rn equals Rn plus 1, which means بقى I slide, which means I slide. So in that case, I will slide to here. So the window will slide to here. And then Rn will become here. And then I will do the same. Is Rn received? Yes. So how many positions in total I will slide in this case, ya shabab? How many positions in total I will slide in this case? Hamza. Hamza, do you know? Hamza Hamad, do you know? ما انا مش عايز ابقى بكلم نفسي يعني. ماشي كويس خلاص بس at least انت متابع يعني. ماشي. So if Rn is received, I will increment Rn. صح? This one is received, I will increment Rn. This one is I increment Rn. يبقى how many positions in total? 3? Yeah. So in that case, I will slide 3 positions because once I get here, once I get Rn to here, I will say that Rn is not received. So in that case, I'll stop. Okay? So remember just the fact that the receiver accepts receiving frames out of order, it doesn't mean that it can deliver these frames to the upper layer. I can only deliver frames to the upper layer only if they are in order. واضح؟ طيب. So when I slide, in that case, I slid actually 3 positions all at the same time, right? So someone might say, okay, so every time you slide, you send the positive acknowledgement بقى, صح? You send positive acknowledgement. So you send positive acknowledgement for Rn, and then you increment Rn, and then the next one is received. So you send a positive acknowledgement Rn, and then you slide Rn, right? You increment Rn, and then the next one. So you send. So, but actually, this is not needed because, as we said, acknowledgement is a cumulative. Okay? So acknowledgement is cumulative. So in that case, if I slide at least once, I can set a flag called acknowledgement needed, right? And then if this acknowledgement needed flag is set to 1, or if it's true, then I send one positive acknowledgement to override all the reception for all the 3 frames all at the same time. واضح كده؟ Because of the fact that acknowledgement is اتفضل. ما هو ايوه ما هو انت هنا you incremented Rn صح؟ So the Rn here will be this one. So it's true. Yeah, so that's how it should be, right? طيب خلاص كده يا شباب. So that's the complicated logic at the receiver. Remember, the complicated logic at the receiver is actually done this way to avoid retransmission of the entire window from the sender side. So we accept frames out of order, but we do not deliver them to the upper layer out of order. So we can only deliver them to the upper layer only if we receive Rn, which points always to a frame that's not been received. Once it's received, I slide the window, and every time I slide, I will have to deliver things to the upper layer. واضح كده؟ طيب. So Yeah, so this is exactly the situation that we are trying to describe. So now the receiver has received this frame just now. Okay, so how many times do we have to slide the receiver window in that case? You see, 3 times. Yeah, so because this one is received, so I will have to increment Rn. This one is marked as received, so I will increment Rn. This one is marked as received, so I will increment Rn. And now, after the sliding, this is the situation now. This is the new situation. Of course, these ones have been already خلاص received, so I'm done with them. And now I'm pointing to frame number with a sequence number of 3, which is the one that's not the one that's not received. And of course, I still have some frames in the window that have been received before, right? That's fine. These are out of order, which I have accepted, and I know that they are out of order, right? So these 3 frames can now be delivered to the upper layer because they are in order. Sure, sure. Right. Yeah, yes, as long as the frames are in order, I can deliver them up, which means there is no gap in between here. All these 3 frames, they are consecutive and they are marked as received. Are consecutive and marked as received, which means there's no gap in between. Okay, if there is a gap, I will stop. يعني هنا there is a gap, I will stop. اتفضل. لا هنا this is the receiver. The receiver slides the window when it receives a frame. Okay, in order. The receiver slides a window when it receives a frame in order, which means frame at Rn, at the first location. Okay, if it receives frames out of order, fine, it cannot slide, it will accept them, but it cannot slide. Okay, when does it slide? If it receives frame in order, which means at Rn. Okay, and when it slides, because the frames in the window are consecutive and in order, then and only then we can deliver to the upper layer. Only under that condition we deliver them to the upper layer. واضح كده؟ طيب, so we'll talk quickly. يعني طبعا بالبات the timing diagram that will make things even clearer now. So all of this wording is actually describing this timing window. So remember, the window at the sender, it slides when we receive an acknowledgement, positive acknowledgement. Okay, so window at the sender slides only when we receive positive acknowledgement from the receiver. Window at the receiver slides when we receive a frame in order. Okay, those conditions, by the way, they apply all the time. Okay, they apply in all cases. Stop and wait, selective repeat, go back in, everything. Okay, again, condition for sliding window at the sender happens when I receive positive acknowledgement from the receiver. Okay, the receiver window slides only when I receive a frame in order. واضح كده؟ So following this, so if I have طبعا هنا the window size is 4 and I have 8 sequence numbers from 0 all the way to 7, so the condition is met. So I'm not expecting any wrong thing to happen here. So it will work as designed. So the sender here has the window at frame 0, 1, 2, 3. So it can send frame 0, 1, 2, 3 without having to wait for acknowledgement. So it sends the same frame. It happens that the upper layer did not send frame 1 on time. So the receiver, because frame 0 is in order, صح? Frame 0 is arriving at Rn, so it's in order. So in that case, the receiver will slide the window, right? When it slides the window, خلاص, acknowledgement is needed, so it sends the acknowledgement. So this is the happy path. When the sender receives a positive acknowledgement of 1, this means that it needs to slide to that particular location and send frame 1. So this is the happy path. Okay? طيب. When it sends frame 1, it happens that frame 1 is lost. Okay? So in that case, the receiver window did not slide, of course, because the receiver did not receive any frame. The sender window, of course, did not slide because I did not receive any acknowledgement. Okay? So the two windows will be at the exact same location. Type. So the sender will keep sending frame 2. So frame 2 will arrive, right? When frame 2 arrives here, this is the situation that's different from go back in. So here, because frame 2 is actually within the window, I will accept it. And because it's out of order, I will send a negative acknowledgement, okay, to the sender, right, to inform the sender that I accepted frame 2, but please send me frame 1 because I want to keep things in order, right? Remember, so the sender will not stop. Sender will keep sending frame 3 because it's within the window, right? And here, the change that I told you to ignore, the receiver will accept frame 3, right? And it will send another negative acknowledgement. And again, this negative acknowledgement is 1. Type. Why is this not shown in the slide? Because of this negative acknowledgement send flag that I told you to remove. Okay? The idea here is that whenever I receive things out of order, I always keep sending negative acknowledgement, negative acknowledgement, negative acknowledgement. So the slides say, why do I have to send negative acknowledgement repeatedly all the time? Only 1 is accepted. لا, احنا, that's fine. احنا, we keep nagging the sender. احنا, we are nagging. So I don't have to maintain that flag. Every time I receive a frame out of order, I will keep sending negative acknowledgement, negative acknowledgement, negative. That's not a problem. And negative acknowledgement is just a signal. It's a small frame, yani, so it will not cause any performance problems. Okay, so this is simplifies the logic a little bit. So we don't have to add a flag, which means that we have to set it to true, we have to set it to false, and so on. We don't have to do that. We keep nagging the sender every time we receive a frame that's out of order. Okay. So the sender now has a situation that it received negative acknowledgement here for frame 1, so it will resend frame 1 again. So frame 1 is resent, which is the one that's lost, right? And because frame 1 has been received, so it fills a gap, so that's why the receiver has slid 3 positions all at the same time, right? So now Rn is pointing to 4. واضح كده يا شباب؟ So that's the main reason that we do not have to go back from the beginning of the one. Now we use the negative acknowledgement to point to the frame that has not been received successfully at the receiver. Any questions so far? تفضل. Right, positive acknowledgement. Positive acknowledgement. As you can see here مثلا, we receive negative acknowledgement. We do not slide. We do not slide. When we receive the positive acknowledgement here, again, we select 3 positions all at the same time, because positive acknowledgement, okay, is cumulative, and it tells us clearly that we have received successfully all the frames before 4 correctly in order. Correctly in order. Okay, so that's why I can slide at further. The last slide in this chapter is the concept of piggybacking. So until now, as complicated as you can see, these techniques particularly go back in and selective repeat and all these events and stuff like that. The assumption that we have made with all these techniques, that the sender is always the sender and the receiver is always the receiver, which means that we have a sender and we have a receiver. So the sender is always the one that sends the frames, and the receiver is always the one that sends the acknowledgement. Okay? In real life, things are bidirectional, which means that the sender is actually a receiver and the receiver is actually a sender. Okay? Which means that in real life, typically, the data link control sublayer supports full duplex communication. Full duplex communication. And we have talked about that in TCP. If you remember, we have talked about the exact same thing. We said that TCP uses acknowledgement number as part of the segment, and this acknowledgement number is optional. It can be filled or it doesn't have to be filled. Okay, so we have a flag, which we call it acknowledgement. If this flag is set to 1, this means that this segment acknowledges another segment. Okay, if this flag is set to 0, this means that this segment doesn't contain any acknowledgement. Okay, which means that in general, I may have a frame, okay, and in the frame I have 2 things in general. I have the sequence number and I have acknowledgement number. Both, okay? So a frame might actually contain new data and acknowledgement, both at the same time. Okay? Why? Because in general, in real life, things are bidirectional. So in other words, we need to combine the sender and the receiver both on both sides. So here the sender and the receiver, and here also the sender and the receiver, which means that in general each node supports 3 events, but now the notification from the physical layer, it can be a new frame and acknowledgement at the same time. Okay, a new frame and acknowledgement at the same time on both sides, right? And also, if we're talking about go back N, each node will have to maintain 2 windows, 2 logical windows, one as a sender and one as a receiver, because again things are full duplex, right? So here we have acknowledgement number and we have sequence number. Okay, so we call this the piggyback. Piggybacking is like what? Piggybacking is like, this is a frame. Imagine that this frame is like a box. Okay, so before we send that box, we say, oh, okay, piggyback acknowledgement here. Okay, so while I'm sending you a box, I will put in it some confirmation that, by the way, I have received already a segment from you. So this is an acknowledgement or a confirmation for the segment or the frame that I have received from you. So we call this piggybacking. Okay, piggybacking. واضح كده يا شباب? So this is the general case that The data link control supports full duplex communication, in which case I need to maintain a sequence number and possibly or optionally acknowledgement number as well. واضح? Any questions so far? Okay. طيب. So this is the end of chapter 11. Yes, Daniel. You always have questions at the end of the lecture. Okay, that's good. That's good. Okay. That's a very good question. It uses neither. It uses actually a mix between the two, and in fact, in the standard does not dictate whether you have to use go back in or selective repeat. You can use either or a mix of both, and you will still comply with TCP. In any case, here we're not talking about TCP, so do not try to confuse yourself. Here, we're not talking about TCP. We're talking about lower layer, data link control, data link layer. So it's device-to-device communication, not end-to-end. Keep this context always in your head. The techniques and concepts are very, very similar. Techniques and concepts are very, very similar to TCP. However, TCP has to worry about congestion control and so on. But here we don't have to do that because it's the two devices next to each other. There's no network in between. Okay, so we do not have to account for congestion here. We do not have to account for congestion. Okay, we have to account only for flow control, not congestion control. Here, flow control only. واضح كده? So just a recap to this chapter. So in this chapter, we talked about data link control sublayer and the main functions of this data link control sublayer. The first one was framing, or how to create a frame, or what we have referred to in Network 1 as encapsulation and decapsulation. So for framing, we talked about bit stuffing and byte stuffing. Okay, so while we create a frame, we have to put the start delimiter, and this start delimiter, we have to make sure that it's not part of the data, in which case we have to do bit stuffing or byte stuffing, right? And then we started to talk about flow and error control, and we said that flow and error control, they work hand in hand. So for flow and error control, we have divided the techniques into two major categories. So the flow and error control, we have divided this into noiseless frame, noiseless channel, sorry, and noisy channel. Okay. So for noiseless channel, we talked about the simplest protocol. Okay, for noiseless channel, we're not expecting any error to happen, neither corruption nor packet loss. So in that case, we talked about the simplest, which has no flow control, and then we talked about stop and wait, which supports flow control. Okay. However, here we do not account for errors. Then we started to talk about the noisy channel. We talked first about stop and wait ARQ. Okay, with automatic repeat request. So in that case, we have to account for corruption and we have to account for packet loss. And then we said that stop and wait is not good in utilizing the channel efficiently, in which case we started to talk about go back in. And we said that go back in is good in utilizing the channel. However, for the case of timeout, it has to go from the beginning of the window and resend everything again unnecessarily. And because of the fact that it supports ordered reception only. So in order for us to support out of order reception, we have to use a selective repeat. Okay, so for selective repeat, we can support out of order reception, in which case when the timeout happens, we send only one frame and not the entire window. So this is a recap for this chapter. This is also where the midterm will cover. So the midterm will cover up to this point. Okay, so anything up to this point is actually included in the midterm exam on March 10th, and I will post the announcement for that exam date. This exam date has been already booked, and